figured out how we can match one or more consonants at the beginning of the word using the RE-match function. And that's really cool, but we need to get back that group of consonants. And we can do that using what are called capture groups. So if we take our expression, and now I'm going to take this bit here, right? I'm going to take that. I'm going to say re.match this expression, and I want to put the whole thing in parentheses now, parentheses, and I'm going to try to match that against, say, the word chair. And now I see I'm still getting back the CH. It still kind of looks the same. I'm going to put that into a match object, and then I'm just going to verify I have something there, which means I can now call the groups function on this. And it will return any groups that I've captured with parentheses. So, right there in the first group, which I can actually get at as group 1, for some reason these start counting at 1, which is nice. I can get back that first capture group. So that is, those are the leading consonants from the word chair. That's really cool. How can I get back the rest of the word? Well, it turns out that in regular expression speak, the dot means anything. So I can say one or more of anything by putting a plus sign. And I want to capture that, so I'm going to put parentheses around it. And now when I run groups, I get back the first part of the word and the second part of the word, which is perfect. Now I didn't have to write a regular expression to do this, and in fact later I can show you how we can do this without that. But that's really convenient. The cost is that I had to learn how to write the syntax. So, in Python, square brackets mean a list. In regular expression, it means a character class. In regular expression, a dot means anything, and a plus means one or more, and parentheses mean to capture an expression. So that's how I can get back those two pieces of the word. And I'm showing here that with match, the consonants here are going to match from the beginning of the string. So we're finding one or more consonants at the beginning of the string, followed by one or more of anything, and that works on chair. But what happens on the word apple? So let's go back and run this on apple, and we're going to see that match is nothing. What is the type of match? It's a none type, because that failed to match. So in the video before this, I was talking about how could we make the initial consonants optional. And it turns out that it also comes to do with these parentheses that we have are also going to make it helpful. This whole expression, we can put a question mark after it to make it optional. So if I go back here and I run this, and I put question mark right here, now everything, the expression before this question mark, so going from this parenthesis to this one, that whole expression becomes optional. And now if I look at my match object, I see that it matched the word apple. And if I run groups on that, I can see that there's nothing matching for the first group. So the first group is still there. It's defined in the regular expression, going from this parenthesis to this one. But the result of trying to match that expression was none. But the rest of the expression matched just fine. So we are able to get the word apple out. So now it works both for apple and it still works for chair. Let's go back and run groups. So the word apple is split into no leading consonants and the rest of the word. The word chair is split into CH and then the AIR, the rest of the word. How does it work on a word that has no consonants? So let's run it on, for instance, Redunzel. And we go look at the groups on this, and it didn't quite do maybe what you expected, because we said we want to match on the consonants, and we kind of think that it would match all the consonants and then something else. Well, we didn't make that something else optional. And so a consonant, that last L, is one or more of anything. The dot here means anything, and the L, the last L in Redunzel, is anything. So it did successfully match some number of consonants up until something else. And so technically speaking, it did exactly what we asked, and that's kind of the problem with computers in total, is that they do what we ask, but not necessarily what we want. So it's very important to go back and think about, for instance, the test here, where when I give it the string redunzel, I expect to get back redunzel and nothing. But if I were to use this code, it would return the RD and Z and then the L, which is not what I expect. So how can we fix this? Well, it turns out that we could make this second part optional by changing the plus to a star. And so this also is the same meta character that we use in argparse. So to say 0 or more, when we're saying in args equals star, we're saying that that number of arguments can be 0 or more. And it's exactly the same in regular expression. So we're saying match one or more consonants followed by 0 or more of anything else. And so if we run that and run our match groups, then now we see that we have redunzel and nothing. And if we go back and run it on Apple, then we run that group, so we get none and Apple, which is great. If we run this on chair, then we get back the ch and the air. Now, this is manually verifying what we want. This is not the way to really share this as code. We need to put all these things that we've worked out into a test suite and verify that our code does what we want. So I'm going to leave it to you to figure out how to take these ideas and write the stemmer function here that will make these tests pass.